Okay, then a quick recap of some of the things that we've been doing in our lessons ready for our test on Wednesday. So first of all, we're going to look at some straight line graphs. And just a quick reminder about graphs that are horizontal and vertical. So if I had a set of axes, the x and y, let's just number these quickly. That's one. So if I had lines that went horizontally and vertically, so remember that the equation of a line is just the rule. So if I had an equation of a line that said y equals 3, that means that we're going to draw a line where all the y coordinates are 3. So if you think about any point that you could draw where the y coordinate is 3, so I could choose, well, if x is 2, y would be 3, that would be that point. If x was 5, y would be 3, that would be that point. If x is minus 3, y would be 3, that would be that point. And if you imagine drawing all of those, any single point, they would form a straight line. And that is the line y equals 3. If I did the same with the next one, I said, well, what would happen if I wanted somewhere where all the x coordinates were 1? X coordinate is 1, doesn't matter what the y is, so I could have 1, 1, or I could have 1, 2, or I could have 1, 5, 1 minus 3. So this line, going this way, that's the line x equals 1. All of those points have an x coordinate of 1. And we can extend that rule and draw other lines as well. So I could say, if I were to draw this line, that would be the line x equals 4. I could draw in this line going across here, and that would be the line y equals minus 2. So that's how we draw horizontal and vertical lines. Okay, the next little section we looked at was on drawing line graphs. So this is the type of question we might have on this. So how can I complete this table and draw the graph for y equals 2x plus 3? So remember, this equation is simply a rule to work out the y coordinate. That's equal to, we do 2 multiplied by the x coordinate, add 3. And I'm going to start up here in the positive side. So if I were to do that calculation, 2 times the x coordinate, well here the x coordinate's 2. 2 times that is 4, add 3 is 7. If I do the next one, 2 times the x coordinate, 2 times 1 is 2, plus 3 is 5. For the next one, 2 times 0 is 0, plus 3 is 3. 2 times minus 1 is minus 2, add 3 is 1. And 2 times minus 2 is minus 4, add 3 is minus 1. And once we've got the table drawn, in a test or anything, there will always be a little grid drawn out for you in axes, but we just plot these as pairs. So minus 2 minus 1 is 1 point, minus 1, 1, 0, 3, 1, 5, 2, 7. So a quick sketch of this graph would look something like, so that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And if we say that's 1, 2, minus 1, minus 2 on the x. So the first point is the point minus 2, minus 1. So minus 2, remember we do the x coordinate first, minus 1 would be here, so that's that point. The next point is minus 1, 1. Minus 1, 1 is this point. The next one is 0, 3. Then 1, 5, then 2, 7. And if you've done it correctly, these points should all join up in a nice straight line. And that's that line graph drawn. Okay, the next little bit we did was on gradient of a line. So remember, the gradient of a line is a measure of how steep the line is. So first of all, if we've got a picture of the line, so let's say I were to draw a line, let's go from here to here. If I draw that as a straight line, to work out the gradient, remember we did, it was the rise over the run or the height over the base. change in y over change in x, however we want to do it. But basically, we just count the squares. So here, I've gone up 3 squares, and I've gone across 4 squares. So the gradient is that rise over run. So that's 3 divided by 4, or 3/4. If I were to do a slightly different one, so let me go something like this. So the difference with this graph is that we're sloping downwards. So remember, that means our gradient is going to be negative, isn't it? Just draw that again. But for this one, we're going to have a negative gradient because it's sloping down. And if we do the same, we just measure our little triangle distances. This is 3 squares across. Going up, I'm going 1, 2, 3, 4, 5, 6 squares up. So the gradient is, and I'm going to put a big minus at the front because I know this one's sloping down if I go left to right, that one's sloping up. So sloping down, it's a negative. And then the rise over the run, the height of the base, 6 divided by 3. And I know that 6 divided by 3 is 2. So the gradient of that line is -2. Okay, the other way we can find the gradient is between 2 points. So remember, if we have 2 points on the line, and if I call the 2 points x1, y1, and x2, y2, try that again, x2, y2, we can say that the gradient is equal to y2 minus y1 divided by x2 minus x1. So, for example, if I wanted to work out the gradient of the line between 1, 5 and 3, 11. So if I wanted to do the gradient between those, I'd say the gradient equals, and then following this rule, you need to learn and remember this, we're going to do the second y coordinates, that's 11, minus the first y coordinate, which is 5. So I'm going to do 11 minus 5 on the top, and the bottom, it's the second x minus the first, so that's 3, take away 1. And the top 11 take away 5 is 6, 3 take away 1 is 2, 6 divided by 2 is 3. So that's the 2 different ways of finding the gradient. If you've got a picture, we do it with the height and the width dividing. If we've got 2 points, we use this formula and we just subtract y minus y, x minus x. Okay, the last little bit that we did on line graphs was the general formula for a graph, wasn't it? And the general rule for any line graph was y equals mx plus c. And the important things about this are that this m stands for the gradient, and this c is the y-intercept. So if we had some lines, could we work out what the gradient and y-intercept would be? So if we do it as a little table, let's do gradient and y-intercept. So if I gave you the line y equals 3x plus 4, the gradient of this is just the number before the x. The gradient of this is 3, and the y-intercept is this number at the end, isn't it? So the y-intercept is 4 in this case. We could write that as 0, 4. The y-intercept is where it crosses the y-axis. That's the y-intercept. If I had y equals minus 2x minus 3, then the gradient here, that's minus 2, and the y-intercept must be minus 3, or 0 minus 3. If I had y equals 5 minus 3x, this is where you have to be really careful. They've tried to trick you in this one because they've swapped the order around. So remember, the gradient is simply the number before the x. So here's my x. The number before it here is minus 3. So the gradient is negative 3. Remember that negative is going with the 3. So the gradient is negative 3. And the y-intercept is just the other bit, which is this. That's a positive 5. The negative's with the 3, so that 5 is a positive number. So the y-intercept is 5, or 0, 5. Right. I think that's about all we've done on line graphs for now. Hopefully that will be really helpful for you as part of your revision.